Hi, I'm GUO CHENG GUANG of Primary 6 from YUMIN Primary School. For this time, we're still at ordinary differential equations. But in ordinary differential equations, we do have many different methods. But each of these different methods, we're going to use exemplification to show us how we can use these methods, different combinations of these methods. Okay, so let's take a look at what type of example we have now and what type of method are we going to use. Okay, so for this example is y prime sine x minus 1 over 4 y cosine square x, and this is 1 minus cosine x, then e to the power of cosine x, then y to the power of negative 3. This is the example this time. Now first analyze what type of example is this. First derivative, non-linear, non-homogeneous. So you have first order, non-linear and non-homogeneous. And that means this general form is actually y prime here first, then plus px y, and this is qx, but behind here still have one more y to the power of something. And this something will represent it as n. And this type of equation, we call it the Bernoulli equation. Okay, so this is a Bernoulli equation. So how about let's try to make it into this form first. So that means y prime, you have to divide sine x on both sides. Okay, so just get something like this. Then after that, well, did you realize for these two parts at the back, they're all the same? That means actually from this first part, we could already straight away let. Now we can choose to use u. We let u be y to the power of, so you get 1 minus this thing. And that is what we should do here. In this case, we write it as y minus x. I mean, this is n. And here they already give us negative 3. So that means 1 plus 3. So it's 4. And now at this part. But here is 1 over 4. Wait, let me just try this bigger. Here is 1 over 4. It's the fourth root. Don't we need plus minus? But in that general case, whereas last time in the previous few lessons, we have proved it and we found that we don't need the plus minus as all the outcomes are the same. Okay, so that one we don't need to worry too much. Then after that, you find the first derivative. Well, if you're interested, you can go back to that video and watch. So now come back here, this is the first derivative. So basically it's both sides differentiate. Okay, so you get something like this. Next part. So you do get something like this. Next part, what would you have? Let's take a look. Well, the only thing left is to sub it inside here. Okay, so then this first part, but let's try to change it into U prime. But at this part, we have done quite a number of these examples, and we realized later on we have to use the integrating factor, or the IF. So how about let's change it into a form, whereas it will be easier to use the IF immediately. How about let's change this cosine square x. We're gonna try to change it into this form. Okay. Okay, so just a second. So wait a second, here's normal y. Okay, here's a u. Okay, I'll check. So from this part, now what kind of changes have we made? First order, well, still first order. Then non-linear, linear. So that means we change non-linear ordinary differential equation to linear ordinary differential equation. Non-homogeneous, still non-homogeneous. Okay, so that means from this part, then we can use the integrating factor, or the IF. So for this IF, let's take a look. Get e to the power of, okay, so it's integrating this part. So for here, we might want to put it to somewhere else and try. So I think for this part, I can erase it. Okay, so I just erase this part. Okay, so let's move that here. So firstly, let's try to find for this top part, just this integration. Okay, now for this part, now what do we have? We can try separating them. Yeah, we can try separating them. And this is what you'll get, okay? So then next, at this part, over sine x, but here it's just x. How can you solve it? what is a little bit of magic here? Well, you can call it a little bit of magic. Now, how does this thing work? You can times sine x on both numerator and denominator. Okay? Times sine x on both numerator and denominator. Therefore, this part you can integrate. So that here is your first arbitrary constant c. Then how does this part work? Sine x, you put it into the dx. After that, integrate. But wait, then your question. Sine x put inside is cosine. How do I integrate this? It's a little trick again here. Sine square x, you can change it into 1 minus cosine square x. Okay, then for this part here, you can go by partial fractions. Okay, then after that, what happens here? So then after that, this part is just to integrate this. Now, when we integrate this, well, then I could just use a bit of space here. So here, for this integration, here you get this negative, right? So you get a negative from there. Wait, but this is a ln. So why not let's just write it into fractions like this. Therefore, this part, can we try somehow to continue simplify that? But at the same time, this negative, I think we could put it inside there and reverse these two orders. But wait, you have another negative here. So how about let's just try to ignore this first? But no, this is from here. So we just put this negative over here. So let's see what we can have. And we want to try to make it cancel out. So what can we have? Now you have this 1 minus cosine x. But what if we times this part on both sides? Then that will be sine, okay, with this inside, sine over 1 minus cosine x. Is that what we want? Okay, yes, I think so. Okay, so I'm just going to write all these out. So here you have your negative. Okay, so your negative half. Then here ln, let me just first times 1 minus cosine x on both sides. Then from this part, 1 minus cosine square x, you can change it into sine square x. So this negative comes in use here. So sine square x becomes sine x. Then this part below is 1 minus cosine x. Okay. Then after that, we're just going to put it inside here. But here we don't have our arbitrary constant c, as if we put it inside and lots of times on both sides, we still have to get rid of that c. And let me just warn you a little bit here. So from this part, you can choose numerator denominator times 1 minus cosine x or 1 plus cosine x. But after that, you just have to experiment a little bit, because right here now, in this matter, since it goes below, so you might be able to cancel out with this. So this part, let me just erase. Okay, so what do we have next? That means it's to times this if, or the integrating factor, on both sides. But wait, can we try to simplify a little bit first? Here you have this log, the natural logarithm. Here you have e, the exponential. How about changing a bit here? Can we change it to this form? And that is when this denominator can cancel out with this. Right? And yet here is even better. Here you have this 4. This side also cancels out. This e to the power of cosine x also cancels out. So here's left with just a 4. The next part for here, it can go by total differentiation. Then after that, both sides integrate. Okay, so next. What happens next? Just integration. So how does this integration go? I think this part is right now very simple. Okay, so now we have this part. Then after that, for this, we'll need to find y, which are right at the top. So we need to find y. Now here y is to the power of 4. When you get down here, you need to divide this with the other side, right? Well, perhaps you could just write it in this form. Then after that, you find y. But here, this is to the power of 4. Now, when you move it to the other side, you now have the positive, negative. Now here in this form we have, this form is the explicit form. How about this? Explicit or implicit? So I believe for up here is implicit, since you have this power of 4 on the y. Okay, we get this y. What can we have next? We're not so sure if this y is correct or not. For this solution, is it right or wrong? So maybe we can do a verification. We can verify. So, do you think this space is enough? I don't think so. So from this part, I think just from here. Okay. Okay, so here is our verification. So verify this right now. So what we're going to use is this part. Well, let me just write down again in case we look at the whole thing. Okay, this is what we get. So when we verify, we differentiate on both sides. Okay, let's start differentiating. Oh wait, these two parts, we might just want to simplify them. This is what you get. Okay, so for this part, I think first part is like this. Then after that, we can try to continue. But at the same time, we can change this into y prime. So then use this 4 divide. Then here you get y to the power negative 3. Okay. Okay, we can try to make y to the power of 4, but since we need to divide it by this, y to the power of 3. So you just get y here. After you need to divide this 4. So you get 1 over 4. So then this part I think is like this. Okay. Then after that is here. Okay. Next, what does this y prime mean? From here it needs sine x. So y prime sine x. Then this part cancels out. Then this part sine also cancels out. Then this part sine squared, well, change it to 1 minus cosine squared x. So what does that mean? That means this part cancels out. Like this. Then after that, what do you get? Here, sine squared x. Wait, sine, you get cosine. Then after that, what happens? Here, this first part is still the same. Then after that, here, can you cancel with anything? Well, yes, you can cancel with this part. Then this part, 1 over 4y, we'll cancel with this 1 over 4y. Then left, this is plus 1 over 4y cosine squared x. Left is this part. Okay, is it the same? Well, it's pretty much the same, just that we can rearrange it. You can minus this to the other side. So they want this order will actually also carry the other order. But to be perfectly the same, we can write it in this order. Okay, so this is what you get. So since here these two parts are the same, that means our solution for this part is all right. So if you like our videos, don't forget to subscribe to our channel. I hope you can understand so far for this lesson. So see you in the next lesson, and thank you for your watching.